All right, class. In this video, we cover page 3 of your lecture handout for section 3.7 on polynomial inequalities. So in this video, we're covering example 2, the second example, and we're going to solve the polynomial inequality x minus 8 times x plus 9 times 7x plus 9 is strictly less than 0. So we're going to find all the numbers, all the real numbers we can put in for x on the left-hand side that will make the left-hand side strictly less than 0. So step 1, same as the previous example, we're going to find all the values of x that make the left-hand side equal to 0. And so those are called the real zeros of the factored polynomial. So we set the left-hand side up here equal to 0, and then apply the zero product property. Either the first factor x minus 8 is equal to 0, or the second factor x plus 9 is equal to 0, or the third factor 7x plus 9 is equal to 0. And then solving those equations, we get x is equal to 8, x equals minus 9, x equals minus 9/7 are the real zeros of the factored polynomial up here. And so those are the three numbers we can put in for x up here, and the left-hand side will equal 0. We then use those three numbers to divide the real number line into intervals. So here's minus 9, here's minus 9/7, and here's plus 8. And again, we have open circles at those numbers because those numbers make the left-hand side of our polynomial inequality equal to 0. Not less than 0. So they're not in our solution set. We then do the test point method for the 4 intervals created by those 3 numbers. And so the first interval in the test point method goes from minus infinity to minus 9. The second interval goes from minus 9 to minus 9/7. The third interval goes from minus 9/7 to 8. And the fourth interval goes from 8 to infinity. And you can see that up here from the real number line. Okay. So in my first interval, I use minus 10 as a test point, and then plug minus 10 into the factored polynomial and got a negative value for the polynomial. So that means any real number less than minus 9 put in for x up here will result in a negative value for the polynomial. In the second interval, I use minus 2 as the test point. I put in minus 2 in for x up here. Got a positive value for the polynomial. So that means any value of x between minus 9 and minus 9/7 put in for x up here in the polynomial will result in a positive value for the polynomial. In the third interval, I use 0. And when I put in 0 in for x up here, I got a negative value for the polynomial. So that means any value of x between minus 9/7 and plus 8 put in for x up here will result in a negative value for the polynomial. And then for the fourth interval, I use plus 9 as my test point. And when I put in 9 in for x up here, I got a positive value for the polynomial. And so that tells me any number greater than 8 put in for x up here results in a positive value for the polynomial. So our polynomial inequality is we're finding all the values of x that make the left-hand side strictly less than 0 or negative. And so we see that the 2 intervals that make the left-hand side negative or less than 0 is this first interval and this third interval. So step 4, I have graphed the solution, right? This is all the real numbers less than minus 9, and this is all the real numbers greater than minus 9/7 and less than 8. And so we see the values of the polynomial are less than 0 or negative if x is less than negative 9, or if x is greater than minus 9/7 and less than 8. And so in interval notation, our solution is all the real numbers from minus infinity to minus 9 in parentheses, union minus 9/7 to 8 in parentheses.